Hello, good morning students. On behalf of Vdvs Vidya Sankul Online Studies, I am welcoming you all of you in this Standard 9 Science Chapter number 10 Gravitation's new topic. Today we are going to start the next topic in the Gravitation's chapter. But before we are going to start the next topic in this chapter, let us take a brief preview on what we have studied so far in this chapter. So we have started the lecture with the basic concept regarding the gravity and the gravitational force. In this universe, any two bodies are experiencing the force of attraction between them, which is called as a gravitational force. The concept is given by the Sir Isaac Newton. He has given the concept regarding that once upon a time he was sitting under a tree and an apple fall down on his head, and then he has discovered that why this apple has fallen down onto his head, why it is not going anywhere else in the on the earth, but it is come downwards to the earth. So from there he has given us the concept regarding the gravitational force. Okay, and after that and long researches, we have seen that this all the gravitational forces are dependent on the factors, and according to that factors we have seen a law regarding that in previous lecture, that a universal law of gravitational constant that we have studied in the in the previous lecture. So if you haven't seen that, you will have to see that. It's a very much important lecture, because all the concept that is coming now in this lecture and in upcoming lectures, we will have to be very clear on the previous concept, otherwise it will make a much more difficult topic, okay, for you. So please watch the previous lecture, and afterwards you can see this lecture. Okay, the first thing that I have to told you is that the thing that we are going to study in today's lecture is regarding this universal law of gravitational constant. So in the previous lecture we have seen the basic law of universal constant is the force is dependent on whatever the force. In this chapter we are talking about the gravitational force. So gravitational force is dependent on the masses of their products of the bodies. Okay, like this. Okay, in the previous lecture we have seen that if a two body we have taken A and B, if they have a mass m1 and m2, okay, there is some technical error, wait for a second. Okay, I don't know what happened, but there is some kind of technical error. So we are seeing that object A, and if an object B has the mass m1 and m2, because they both have a different mass, so how can we identify them? We will have to take a m1 and m2. It will be considered as a different masses. Okay, otherwise we can, if it has the same mass, then I can write like this, m and m, but it has a different mass, so that's why I have written m1 and m2. Okay, now they are on the distance at a d. Okay, so we have seen in the previous lecture that these force between them, the force between these two objects is dependent on the product of their masses, m1 multiplied by m2, and it will be inversely proportional to the square of their distance. It means whenever we are increasing the distance, it will automatically reduce the gravitation force between them. You have already seen that topic, okay, in the previous lecture. So basically this is the dependation of force. Okay, then we have added some kind of constant into that, and that constant is known as a gravitational universal constant. Sorry, universal gravitational constant. Then we have make the formula is G is equal to F into d square upon m1 multiplied by m2. And then we have make the SI unit regarding that. In that we have seen the unit for gravitational constant is Newton meter square upon kilogram square. Now you already know in the mathematics rule, if we take this denominator square into upward, then it will be considered like this: Newton meter square into kilogram inverse square, like this. Okay, if you want to write, otherwise it is a right. Okay, and these both are right. You can write like this. Okay, don't worry at all. If you want to write like this, Newton meter square per kilogram square, it is also okay. These three things are always equal. Okay, don't worry about that. So this is the basic idea that we have already seen in the previous lecture. In today's lecture, we are going to start with the first concept, and that will be the Kepler's law of motion, in which we are going to see one law regarding the Kepler's motion. The law is very easy. He has given us the idea regarding the elliptical motions of the planet. He has discovered that in this universe, the planets are revolving around the sun, but they are not rotating around the sun in the circular path. They are revolving and rotating around the sun in an elliptical path. Elliptical means a egg-like shape. Okay, elliptical means what? A egg-like shape, like this. So he has discovered that if the sun is here, then this planet is revolving around in the elliptical shape. Okay, it is not revolving like this. Okay, it is not revolving like this. So he has given us the idea regarding that. So that's what we are going to study about that. So why we are studying this in the gravitation chapter? The important thing is what? Why this topic we are studying in the gravitation chapter? Because if you have noted or not, the elliptical shape makes a gravitational force different at each and every place. That's why. See, here is the sun. So whenever we are nearby the sun, we are experiencing a much more gravitational force towards the sun. And whenever we are away from the sun, we are experiencing a less force regard. But it does not mean it is so much less that we cannot be thrown away from our orbit. Okay, so it is that much high that we can still rotating or revolving around the suns. Okay, so it does not bother us that it is going to remove from its orbit. So that's what we are going to see in this law. After that, we are going to study about that why these elliptical shapes are interesting to us. Okay, now we are going to see that. I will take one blank slide so you can all understand that. See, that's what we have already studied. These are all the topics that we have done in the previous lecture. I am going to just find out one blank slide. Okay, this is a blank slide, so we can write down all the things here. Now, why we are so interested in these elliptical shapes? Because you have heard the things like that whenever we are launching a mission. See, this is our path, and this is the basic idea of, still I am changing a color. So here is the earth, suppose, and here is a mass. So we have seen that whenever we are rotating, whenever we are revolving on the elliptical path, then at some point we are nearby, because the revolving path is so much different that whenever we have finished a one rotation, okay, the mass has been still here or maybe here. Okay, we have seen that. But at some point in the year that we are so much nearby because of this elliptical shape. Otherwise, what happens? The circular path has been not given us like the concept regarding when we have to launch the missions to go on the Mars. Okay, so this elliptical shape makes it easy that we are getting so much closer, and that's where we are going to launch our mission regarding the Mars, regarding all the other planets. Okay, but while in the circular path it is not so much easy, and the all planets are experiencing the same revolution, same gravitation force of the sun. So that is not possible at all in the circular path. Okay, because if what happened, if the mass is traveling here and we are traveling here, so no point where we are going to go nearby the mass, because of the rotating path is circular. So we and also mass, they both will experiencing a so much exactly equal gravitation force. So Mars will rotate in this format and our Earth is rotating in this format. Okay, so there is no such a point that we are coming closer to each other, and that's why it makes a sense much more in the elliptical shape, that from the elliptical shape we can launch missions wherever we want to go. We can go where, because in elliptical shape at some moment we are come closer to each other. That's why. Okay. Another thing, that why these elliptical shapes makes much more sense, because after so much study, now we have discovered that in the galaxy the sun is traveling in the straight path. Okay, you all have heard the concept because of the sun is stable here. Now in actually what happened, the sun is here. I will change the color. Now your sun is here. Sun is still traveling in these galaxies continuously, and all the planets are rotating around its orbit like this. Because sun is continuously moving, so all the planets are revolving around its orbit like this, elliptical shape. And second planet is also revolving around this, and this model is called as heliocentric model. And because of this, we have understood this topic. Otherwise, what happened? A sun is traveling and all these planets are rotating like this. Okay, all the planets are rotating like this. But now we have understood, because of this elliptical structure, that a heliocentric model is still exists in this universe. Okay, so we have seen that. Okay, that's why it makes much more sense. Now, what we are going to see afterwards, that we are going to see that topic again, but then we are going to study about the Newton's second law and Newton's third law, because Newton's first law we have already seen and we have already derived the equation regarding that whenever we are experiencing a force, it is dependent on the masses of their product of their masses regarding their bodies, and it is also dependent inversely to the distance. Okay, that we have seen regarding the first law. But in the second law, we have seen in the chapter number 9, force and laws of motion, that force is acting on basis of mass and acceleration. Now in this chapter we are going to study about that. So for that, let us take that topic in the brief. Okay, see, all these things we have already studied in the previous lecture, where we have studied about, okay, the force, gravitational force. Okay, see, here is a one important point. The gravitational force is the weakest force in the nature. Okay, because if you think clearly, the bodies are experiencing a gravitational force towards each other. Okay, but our earth surface has a much more gravitational force, that's why it is not come closer to each other. Okay, it will stay there. Okay, otherwise what happened, if we are increasing the masses of their bodies, then some point they will collide with each other. So it is not going to happen, because our earth's gravitational force is so much higher, that's why. Okay, so whenever we are talking about the two bodies, in between them a gravitational force is applied, it is a V case because of our earth's gravity. It is an attractive force. It is mutual force. First body attracts the second body and the second body attracts the first body. It's a mutual force, means the both bodies experiencing the same thing. It is a certain central force acts along the line joining the centers of their body. It is a masses and distance dependent. That are the things that we have already seen in the previous slide. So we are not going to waste any kind of time in that. See, here is the SI unit that I have already told you. Now the thing that we are going to see is here, I think. Here is the first point. Kepler's laws of planetary motion. Now here is the concept that we have already discussed. Every planet moves around the sun in elliptical orbit with the sun at one of the foci of elliptical orbit. Means the sun is here in the focal point. So our sun is here, okay, at a focal point, and all the planets are revolving in the elliptical shape. Okay, so that is a simple topic, but they have given us a figure. So I am giving you 10 seconds of time so you can watch all the orbits regarding our Earth. Okay, here is our Earth. We have already seen that topic. Now that you have seen this thing, let us take another topic, Newton's second and third law of gravitation, not the force regarding, but we are studying the second and third law in the reference of gravitation. According to the second law, the force is basically dependent on mass and acceleration. Okay? According to the Newton's third law, here it is not given in any kind of reference of the second law, but we have seen the second law is here. Okay? Here it is the second law. So we are going to see that after a third law. So every object attracts every other object with a gravitational force. These forces are equal and opposite because we have seen that whenever you are taking an action, it will automatically give you a reaction. Action and reaction are always equal and opposite in the direction. So likewise that whenever we are applying the force in this direction, what we are experiencing? We are experiencing the reaction regarding that in the opposite direction. We can basically understand by this concept by the concept of friction. Like whenever we are applying the force to move an object from one place to another place, what we are experiencing some kind of friction force opposes our actual force, and that's why we'll have to make a much more effort to move the object from one place to another place. Okay, because whenever we are moving the object, if it has a much more mass, then we'll have to make a much more effort. Why? Because the friction force is also acting opposite and it is also equal. It will try to oppose as much as possible. So that's why we have to make so much effort. Okay. Another thing is that therefore both the objects must be moving towards each other due to the force. Okay. Then, however, due to very weak nature of force, the normal sized bodies are not seen moving towards each other. Otherwise, what happens if when we put two bodies near by each other, they will come closer to each other because of this gravitational force between them, force of attraction between them. But Because why? Because from the our Earth's gravity is much more higher, so that's why they will stay at the point they were. Okay. What happens when a ball dropped from a certain height from the ground? Ball is seen falling toward the Earth, but the Earth is not seen jumping. See, when you are small, you were thinking about that. When we throw a ball, due to the gravity, ball will come closer to the Earth. Okay, but why, if the force of attraction between them is same, then why Earth is not pulling towards the ball? Why ball is pulling towards the Earth? Because you have now understand that because it has a much more higher force than the ball's force, and also it has a much more mass into the comparison of the ball. That's why the ball is come pulled towards the Earth, and that is the reason that the moon is also revolving around us. Okay, because it consists a less mass than us. That's why. So according to that, Newton's second law, force is dependent on the mass and the acceleration. Let m and m be the mass of the Earth and the ball respectively, and a be the acceleration by the gravitation. So here is the concept that this is the force that applying on the Earth, and that is the force that is applying on the ball. So they both were equal, and now they have compared that. Okay, that when we are experiencing acceleration, it is given by F capital M in the Earth, while in the ball that is a F is equal to small m by E. Okay, here is the concept regarding that. Sorry. F, sorry, A is equal to F. I think I have written a wrong formula. F upon small m. Now this is right. Okay, ready. For the ball's acceleration, and for this is the Earth acceleration. Okay. Now according to that point, now we are going to study about the free fall. Now what is the free fall? I will change the color, because sometimes the brightness gets much more higher. That's why I am highlighting this, so that you can read it carefully. Now in the first lecture, I have already told you the concept regarding the free fall, in which we have studied about what is a free fall. So if we throw a ball, or if we throw this pen into the air, at some point it will reach the peak point, whatever the force we have applied on the ball, or whatever the force we have applied on the pen, then it will goes to there, and then it will come back. And now nobody is going to apply any kind of such a force into that pen. Nobody is going to apply a force onto the ball that we have thrown into the air. But still, without any force, a ball or a pen is coming towards the Earth's surface, because of the gravitation force are acting between them. And that's the only reason that the ball will come on and hit the surface of the Earth. Okay. So the things that we are studying is without actually giving a force. What happen if we throw a ball from the rooftop, and what happen if we throw this feather from the rooftop of the our building from to Earth? Then what will reach the Earth's surface first? Okay. Again, I am repeating the example that whenever we'll have to stand at a rooftop at our building, we'll have to take two things with us, ball and a feather with us. Okay. Now I will just throw the ball, not like this, but I will just let it go. Okay, ball and feather both will let go from my hands like this simply. Now they will both will come. For instance, they will at some point they both have to come on the surface of the earth. But you will have to think about that point, that from these both things, what is the first thing that will come to the surface of the earth? What is the first thing that will make an attraction attract towards the earth? Okay, what is the first thing that will hit the surface of the earth? So the first thing that will hit the surface of the earth is ball. Okay, you all are right. You all are thinking right. That ball will hit first, and after a long time, the feather will goes like this, and then it will eventually hit the surface of the earth. Okay, but ball will hit the surface of the earth much more at a faster rate. Okay, so why this happened? We have let go both the things at an same time, but we have experienced that the gravitation force is also acting same onto that, because we are standing at some actual distance from the earth, so they both objects have to experience the same gravitation force, but it will not make a same it will not affect the it will not experience the same equal gravitational force because of the one reason, and that one reason is a mass of their bodies. Because of the masses of their bodies are different, they will eventually experience a different gravitation force. Okay, so if a mass is much more higher, it will experiencing a much more greater higher gravitational force, and if the mass is less, then it will actually experience a less gravitational force according to the second law of motion of Newton. Okay, because force is dependent on directly to the mass and the acceleration. Now we have let it go the acceleration. We haven't making any kind of force towards this thing. We haven't throw the ball. We just let go the ball. We just let go the feather. Okay, so from that point, the acceleration is now not that we are making an acceleration. We haven't given any kind of force. It will experiencing a force, and now the acceleration is also. See, now that is the point that we are discussing in this law. That acceleration. Now you already have heard a word. Wait a second. Now you all have heard a word. You have all heard that whenever you are come closer to the earth, it will make your speed much more higher. Okay, whenever you are stayed away from the earth, then you are experiencing a less amount of gravitational force. But whenever you are so much closer to the surface of the earth, you will collapse like this. Okay, you will experiencing a high attraction force. Okay, the thing is that whenever you are reaching to the surface of the earth, that makes the thing, and that thing is we are experiencing an acceleration because of the gravity. Okay, and whenever you are so much closer to the earth, you are experiencing a much more acceleration because of what? Because of what? Gravity. Okay, so gravity is now directly dependent on our free fall bodies. Okay, of their acceleration. So we can say that acceleration is fully dependent on what? It is fully dependent on the gravity. Also it is dependent on the mass. Okay, because we have seen that. See, here is now example we are going to see that when we throw a feather, it will take a long time, while we throw a 5 rupees coin, it will take a less amount of time. Why? Because of the masses. Okay, masses are different for both objects. Okay, and it will eventually hit the gravitational force. Here is the surface of the earth, and here is the gravitation or gravity. and if they are experiencing some kind of acceleration, it is also because of the gravity. So we can replace the acceleration term by the gravity. For the gravity we are going to use the term g, small g, because we have taken the capital G as the universal gravitational constant. So now we are not going to take this capital G, we are going to take the small g for the gravity. Into the next lecture we are going to see the replacement of the second law according to the free fall. I have already told you the whole phenomena. In the next lecture I am going to explain you the equation regarding that. Okay, so that's it for today. I am not giving any kind of homework because it is a fundamental concept, so you just have to understand that topic. Okay, there is no homework in today's lecture. Thank you very much for reading this lecture. If you had any kind of doubt, you can ask me on the comment section. And also please stay safe, stay at home, wear mask, okay, whenever you go outside, and wash your hands regularly, sanitize your hands. We'll meet in the next lecture. Till then, bye bye everyone, and take care of yourself.